Captions in English, please. So this is the 5th video of chapter 3, and it's going to focus on changes of matter. So how does matter change? So again, there is physical changes and chemical changes. And the physical changes are the processes that do not alter the chemical makeup of the starting materials. So changes in physical state, for example, are all physical changes. And the illustration here shows you an example of, change in physical states for water. If you look on the left, you have water as ice. It's an ice cube in that bowl. It's been heated. And if you look at the schematic of the structure of the ice, it's ordered into a lattice, but the base is the molecule of water, right? Then when you are melting the ice, it becomes a liquid. And if you look at the second schematic, you see now it's liquid water. And the molecules of water now are not arranged in a particular order. There's no pattern. It seems random, but they're still packed together. And that's still water. The molecule is the same. And then when you go from liquid water to the steam, gaseous water, the steam is not really shown, but it's because the molecules of water now are dispersed very far from each other and flying around. But it's still the molecule of water that is making up this sample. So changes of physical state are physical changes. You're not changing the starting material into another new substance. Another physical change is when you're dissolving a table salt or sugar in water. So let's look at an animation. So this animation from PHET Colorado EDU will show you what happens when you are pouring salt. So let's pour some salt in that water. We have a liter of water, and so let's pour some salt. And then let's test the conductivity of the solution. So I'm going to take the conductivity tool here, and if you dip the 2 electrodes, you see that the bulb is lit. So that means the solution is able to conduct the electricity from one electrode to the other. So that means the salt water is able to conduct electricity. Let's look at the microscopic level of this solution of salt. And let's pour some salt in there. So this time we are seeing at the macroscopic level what it looks like. And according to the legend, we have sodium ions and chloride ions, Na plus and Cl minus. So you see that they carry a positive charge and a negative charge. So these are ions. So they are charged particles. And that's why salt water is able to conduct electricity. It's because one electrode will attract the negative ion and the other electrode will attract the positive ions, and this way the electricity can be conducted because charged particles are moving and conducting the electricity. So that explains it. And now if we look at the water level, let's put some salt in there. So you see how water is always moving. There is that random motion that is normal. And then if we put some salt in there, you can see how the salt is separated into single ions. And right now there's only one sodium ion, but the other ions are each separated and surrounded by molecules of water. Let's try all of this now with sugar. Let's pour some sugar in there. and see if it can conduct electricity. So now we have a solution of sugar in water. Let's test for the conductivity. Here I'm dipping the 2 electrodes again in the solution, but this time the bulb is not lit. So that means the sugar solution of sugar and water is not able to conduct electricity. And at the macroscopic level, let's remove the solute here and change that to sucrose. Let's pour some sucrose in there. You see now how it's a much bigger molecule. It's made of carbon, hydrogen, and oxygen, and it's a very specific shape. All the molecules are the same shape, same formula. It's a large molecule, and there is no charge, right? Sucrose is a neutral molecule, and so it's not attracted by the electrodes, and that explains why there was no, electricity was not conducted. Now at the water level, if we put sugar in the water, what will happen? Well, again, the particles of sugar or the molecules of sugar will become separated and surrounded by water, just like the ions for the salt were separated and surrounded by molecules of water. So this shows you again what happens if you place a solid piece of sugar in water. And let's say that the solid piece of sugar was that size at first. So the molecules of sugar are all packed together. And you can see that actually the molecules of sugar get surrounded by molecules of water, and that's how the water, takes one molecule at a time and then surrounds it, and that's how solubility works. The water, if the solvent is water, will surround the surface of the solid and take one molecule at a time, and will take it away and surround it. And that's how we are able to dissolve sugar in water, for example. So how does matter change? We said there are physical changes and chemical changes. What are chemical changes? It's processes that change the makeup of the starting materials. So really a chemical change is synonymous to a chemical reaction. A chemical change means a chemical reaction occurs. And here you have a model of the reaction of hydrogen, and you have 2 molecules of hydrogen, H2, and 1 molecule of oxygen, O2. We will make them react, and so these 2 are gases. And if you make them react and trigger the reaction with a spark, it's a very explosive reaction, and you obtain water. Let's look at a video that shows that.
When the 2 gases are mixed, a spark will cause them to react. The atoms explosively combine as a pair of electrons become shared between each oxygen and 2 hydrogen atoms. A closer inspection of the inside of the container shows water vapor condensed on the cool container walls.
So you've seen how explosive the reaction was and how quick, right? Oxygen and hydrogen make a very explosive reaction to form water. So other examples of chemical changes are oxidation of matter. So like rusting of iron is oxidation of iron. Any kind of corrosion is an oxidation. Typically, that's what happens to metals, for example. Whenever you are burning something, it's also an oxidation of matter, and burning wood, magnesium. So here the left picture is showing the burning of a piece of magnesium, most likely because the light is very, very bright, intense. It hurts the eyes to look at it. And in real life, if you watch such a burning of magnesium, you don't want to stare at it because the light emits a lot of UV light that is bad for the eyes. So you want to not look at this straight into the eyes. Another example of change, chemical change, can be the formation of insoluble solids when you are mixing two solutions. And the solid that is formed is called a precipitate. So we call those precipitation reaction, where you're forming an insoluble solid. And here you see that the two starting solutions are aqueous solutions. You know, they look like water, both of them. But when you mix them together, there is a white powder, yellow powder that is forming. And that yellow powder is a solid, right? It's in the form of a powder. That's why it's, you know, in solution like that, in suspension. But if you let it sit, it will decant and settle down at the bottom of the beaker. And if you would evaporate all the liquid, then you would be left with a solid powder, yellow powder. So that's a chemical change, right? There's the definite change visually. Anytime you have a release of heat or light, emission of light, there is a chemical change happening. And let's look at the formation of sodium chloride as an example.
A small piece of sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.